Okay, here we go. Unit 5, Lesson 1. What I love about Lesson 1s in general is it's just kind of like a nice, easy introduction. But Unit 5 is all about solid geometry. So we're getting into like 3D geometry, which is pretty cool. But anyway, solids of rotation, bullet point says, let's rotate two-dimensional shapes to make three-dimensional shapes. So, okay, so 2D is like a square or a triangle or a rectangle or a circle. And if we rotate them, that's how you start to make 3D shapes. So anyway, more on that in a little bit. 1.1 is really easy. Which one doesn't belong? So what I want you to do is come up with the reason for A, B, C, and D. You could come up with reasons, multiple reasons for each letter. So let's look at the slinky. The slinky looks like the only one that can actually change shape. Like the Rubik's Cube, well, technically you can move around a Rubik's Cube. But the slinky, I mean, if you close it, it's a cylinder, but the slinky can move around. So it's also the only one that's like open. So you could say like it changes shape. It's the only one that's not like a complete solid. And has some openings. So there's 3 reasons why the slinky is a little bit different from the hut, the Rubik's Cube, or the foam roller. Okay, for the foam roller, let's see. How is this one different? Well, let's think. How is the foam roller different than the hut, slinky, and the Rubik's Cube? Well, it is the only like solid cylindrical shape. I mean, the slinky technically is too if you close it, but this foam roller's much more of a solid shape. Let's see. It's the only one you'd find in a gym. That's a foam roller, if you ask me. I used to use those foam rollers at the gym to kind of loosen out like sore muscles. Some might argue this is a piece of chalk, but you've got a circular base. This is definitely a cylinder. All right, C. Let's see. This is the only building. Looks to be a building to me. In fact, I might argue that's somebody's home. I'm not sure though. Looks like some sort of hut. It's the only one of the 4 that's got a cone shape. All right, let's go to D. The Rubik's Cube. So this is the only cube. It's multicolored. I suppose you could say this one is too. It's multicolored. And a student yesterday was really insightful and said, there's a bunch of cubes within a cube. So multiple cubes within the larger cube, which I thought was really cool. Like this white, red, and green one. That's a cube, technically. They put them all together, so cool. All right, 1.2, axis of rotation. So your teacher will give you a shape. Tape one side to a pencil. In the interest of time, I didn't have students actually tape the shape to the pencil. I did it myself. But basically, we have a pencil. This is a rectangle. You got to think about it like spinning around. I'll try to get this on camera. So you spin this shape around. What shape is it forming? Now, the way you can think about it is, let's look at the top. If you spin this pencil around, you see it's forming circles up top, where you could envision this as the radius. So you're spinning it around, it's creating a circle up top. It's also going from this side over here to the other side. That's like doubling in size when you spin it. So think about the top and the bottom forming circles. The rectangle is going to form a cylinder. So the rectangle, when you rotate it, that goes to a, I'll draw it a little bit closer to good representation here. So, cylinder. All right, let's do the next one. The next one is it's actually a right triangle. So I'm spinning this one with the pencil. You can kind of see what shape is forming. So imagine a right triangle over there, right triangle over here, and then the top remains unchanged because it all comes to a point or an apex. But as you spin the bottom, that's creating another circle. So a two-dimensional triangle, we're spinning it like so. You can probably visualize this. The shape that's traced out, or the shape that is formed by rotating this pencil, which is known as the axis of rotation. The pencil is the axis of rotation. You'll see this triangle is starting to resemble a cone. So, got our pencil, drew a right triangle, we spun it around, that became a, I'll try to draw it true to form as best I can. So, 2D, 3D, 2D, 3D. The rectangle became a cylinder. The triangle, which was 2D, became a cone. Pretty cool. Okay, one last one. This I used a compass. So we have what's called a semicircle. So let's spin this and see what kind of shape is created. Ooh, there's the other half of the semicircle. So we're spinning this semicircle. Now watch the top. Now, there is a top and a bottom. It's gonna resemble, I should have drawn a globe. That would have been cool. Oh, could have done it on the back and the front. Could have done the Eastern Hemisphere and the Western Hemisphere. Anyway, getting carried away. But we're rotating this pencil, which is the axis of rotation. We're rotating a semicircle, and the term you need to know is the solid of rotation. So the solid that is being formed is a sphere. Where's a sphere? Let's see. Here's one. My first year student used tape to create a basketball kind of setup. Anyways, the very last one was a semicircle. So 2D was a semicircle. Now when we rotate it, when we rotate the pencil, that became a 3D. Should have used the compass, but that's okay. That's supposed to be a shadow. Became a sphere. So semicircle. You rotate it on a pencil, becomes a sphere. Now, the axis of rotation in this problem was represented by the pencil. The pencil was the axis of rotation. And then we formed 3 solids of rotation. The solids of rotation are the 3D shape formed by rotating a 2-dimensional object with an axis of rotation. And a 3D shape that was formed included the cylinder, the cone, and the sphere. So if they ask you what's the solid of rotation, that's going to be the final 3D shape formed. Okay. Nice job. On to the next, and then we're done. Oh, this is so easy. Kind of fun, too. All right, so from 3 dimensions to 2, draw the 2-dimensional shape that, when rotated using the given axis of rotation, produces each solid of rotation. Ignore, so don't pay any attention to any non-symmetric aspects of the solid. So, what does that mean? Okay, so what you're gonna do here is first, you gotta identify that there's a line of symmetry right here. So I'm just gonna draw this like half of the vase, basically. Does it have to be perfect? No. It's a drawing. That's why art's so fun. does not have to be perfect. You get to do your own spin on things. Anyway, starting to look like a half of a vase. Add some color, make it fun. Always remember, coloring is therapeutic. So if you're ever really stressed out, try some coloring books. Okay, there's the vase. All right, check out this wedding cake. So again, you're gonna have a line of symmetry right there. So why don't we try doing the lines first? A little bit bigger. Now, when they say ignore non-symmetric aspects of the solid, that'd be like the flowers. Those are not symmetrical, but it's okay. Looks about right, just barely. I got another one over here. Okay. Hey, maybe you want to draw a flower too. Make it fun. Who knows, maybe you want to design wedding cakes when you get older. It's a lucrative business. That was a terrible line. Oh well. Not going to be a perfectionist today. That orange brown. Some orange. I encourage you to have fun with these as much as you can. Geometry is not life and death. Okay, next up we got a dumbbell. Kind of like one of these. Woo. All right, so you got to draw a dumbbell, half a dumbbell. And you can envision it like this. There's your line of symmetry. So I'm just gonna draw this. Oh, the middle is ½ inch. Okay, looks like it comes up here a little bit. These are all like weights. Probably like 2.5, 5 pounds maybe. And when they get smaller, as you go on. gray and brown. Now, do I want you to make your pictures as good as you can? Yeah, I do. Why not? Always in life you want to put out quality work if you can. Why? Well, it's more interesting. Seeing more silver right here. Okay, the bagel. So, think about this bagel. There's pretty much a line of symmetry right there, right? Okay. Why do you think it's darker on top and not in the middle? Or darker on top, lighter in the middle? Well, I think these are baked in like a oven or toaster. And the middle part wasn't as exposed to the heating source. That's what I think. So the outer edges got darker. The inside, a little bit lighter. Nice. There's my bagel. Okay, just have fun with these, you know? That was it, 1.3. So this is the solid of rotation. The pictures are the solid of rotation. These lines are your axes, plural for axis, but each of these lines serve as the axis of rotation, similar to the pencil. All right, let's look at the lesson summary. Then I can't wait to show you the new art whiteboard, and we'll call it. So take a coin, spin it on its edge. Okay, quarter works. Give it good speed and make sure it stays vertical. Again, quarter, spin a quarter is kind of fun. What shape do you see? When you spin the coin, you should see a sphere. This triangular flag is made of metal. Whoa. Looks almost identical to that. What shape will you see if the pole is spun quickly? You're going to see a cone. When the flag rotates with the pole, you should see a cone, which is cool because look at these individual triangles. Look at these individual triangles. I don't know if you remember this, but check this out. I'm trying to get this right. So you got center. But think about all these triangles. They form right triangles everywhere. This is going to come in handy when you talk about the unit circle, which is the future. Anyways, take a look at all these little triangles that are formed. Let's do it. At an angle. Triangle. 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 That's what they're showing you here. But anyway, this forms a cone. So in both pictures, the object spins around a line called the axis of rotation. The pencil is the axis of rotation. The solid created is called the solid of rotation. So the 3D solid. That's the solid of rotation. If you were to spin the flag using a different axis of rotation, you would see a different solid of rotation. This is what it looks like when the flag is rotated using a different axis of rotation. Interesting. A machine called a lathe cuts away at a rotating block of material. A lathe could be used to make like chess pieces, for instance, or a decorative sculpture shaped like the figure on the right from a block of wood. That almost looks like a... Just needed a crown, huh? Let me see. I got one. All right. Imagine chess pieces, the queen. Anyway, the image on the left shows the cross-sectional shape that would remain after the lathe carved away a part of the spinning block of wood. If we rotate this two-dimensional shape using the vertical axis shown, it produces the sculpture shape. And what we're going to get into soon are all these cross sections. I believe that's next, cross sections. Anyways, that was lesson 1. Don't ever forget your practice problems. Got to do the practice problems. They start on page 206. I cannot wait to show you this whiteboard. I've been having fun lately. Here we go. I did the seed of life. So quest for number 6, go Niners. Super Bowl on Sunday. But the seed of life, 6 petals in the middle. 1, 2, 3, 4, 5, 6 plus 1, 2, 3, 4, 5, 6. Symbolizes flowers, snowflakes, many forms in nature. also. Yeah. What else do you see? You see a hexagon. Notice that the intersection points are like the hands of a clock. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Pretty sweet. Seed of life. Super fun. Then we did the yin and yang symbol. It's a traditional Chinese symbol that represents duality, symbolizes balance and complementary forces. So opposite forces are interconnected in the natural world as yin and yang. You make this symbol with the seed of life as a starting point. It's pretty cool. Oh yeah, I almost forgot on the seed of life. It also symbolizes perception and the measurement of time, which is pretty cool. 7 circles symbolizes the 7 days of the week, the 7 chakras, 7 colors of the rainbow, 7 deadly sins, 7 heavens, 7 days of creation, 7 seas, 7 continents, 7 wonders of the ancient worlds. Cool. All right, Trinity knot. This one is super fun. These are all sacred geometry drawings that you can do. They're in that book that I have, but the Trinity knot is generally thought to represent the mind, body, and spirit. Common ornament in medieval architecture, literature, and legends. The divine Trinity and religious symbolism. They all came from this book right here by Ana Victoria Calderon. Thank you so much. I love that book. Classroom's looking good. Here we go. Got our points board updated. Borrowed a slide projector. All right. Have a good day. Do the homework.